Hello and welcome to the 10-week courses overview for Module 1. If you are taking General Chemistry 2 in 10 weeks, man, kudos to you because there is a lot of material that is covered. It is doable, just make sure that you allow plenty of time to process the information so that you can actually retain it and do well. I highly recommend making up some little summary pages yourself as you go along, screenshotting them. Remind yourself to look at them with a little alarm, just to keep the information fresh in your head. So this week, part 1 is going to start off with liquid properties and intermolecular forces. Then it's going to move over to heat curves and vapor pressure. And finally, you're going to end with solutions, solvent, solute. This is also about saturation and electrolytes. So what does this really mean? So with liquid properties and IMFs, you're going to be looking at ideas like boiling point, freezing point, capillary action, viscosity, surface tension, all of these ideas in here. And then you're also going to be learning about vapor pressure. So these are all basically liquid properties. These are for pure liquids. You're also, in the third section, going to learn about how some of these properties change when you've made a solution. And then you're going to learn something called phase diagrams. And you're going to learn that this is where the solid region is. That's the liquid and that's the gas. And you're going to learn about those little points in the middle. They're going to mean something. So you get a lot of questions on these. These are really popular kinds of questions to put on, like the cumulative ACS exam. Like they just pop up a lot. It's just like a favorite topic for people. So make sure you're really good on phase diagrams. And then right here, this is the biggie. If you're going on to organic chemistry, the hydrogen bonding, that's huge. It's going to come up a lot in organic chemistry, but even the dipole-dipole interactions, lone dispersion, this is all will come back with a vengeance in organic chemistry. Hydrogen bonding is when you have a hydrogen with NO or F. Dipole-dipole goes back to general chemistry when you learned about polarity. And then London dispersion, this has to do with like random electron distributions. And you also review when something's ionic. Now, when we go over to heat curves, this section right here, vapor pressure, was in the list on the left side. So these are more about learning to use some formulas and also reviewing logs. So in this case, in the orange, we have this thing, it's called a heat curve. It's funny though, because it doesn't really have any curvy parts. But right here, this section, this section, this section, all of those with the blue arrow to them, if you, like, they'll give you a heat and then they'll give you a temperature. And it's kind of like you figure out which equation to use. So if it's on this horizontal line, you use that. And if it's on like these diagonal ones, then you use that equation. So the heat curve is about kind of like you get a graph or you're told information and you can kind of make up a graph that looks like that. And then you decide which parts of these formulas, which formula applies for where they are in the graph. And then eventually you get to the point where you can actually do ranges and you can like figure out how much energy was used to go all the way from one range to one range by adding up the Q's. So those are heat curves. And then vapor pressure, right before you get to it, you're going to review some logarithm properties just in case you forgot. You can see that when you do e to the natural log of x, that's the same thing as just saying x. And then also true for the log of 10 to the x. So you're going to review that, and then you're going to look at this equation, and you're going to be able to solve for something inside a natural log right there, or solve for something over here. So vapor pressure, what it is doing is it's basically letting you predict the pressure of a vapor, of a substance, at a different temperature if you know the pressure at an original temperature, and as long as you know the enthalpy for the substance itself. Finally, in solutions, so solutions, solvent, solute, saturation, that's looking at, this is a funny picture here, but the blue is a liquid, and if you're putting enough white powder in that it stops dissolving, it'll just like start forming this little curved area at the bottom. So when it does that, that means that the water is saturated. You can't get any more of this to dissolve at that temperature. Regardless of how much you put in, you just can't get any more to dissolve. So that's something saturated. So you're going to learn about saturation, and then you're going to learn about saturation curves. And that doesn't really look like a curve as much the way I drew it, but you're going to learn about like how when you're above the curve, it's super saturated, when you're below, it's unsaturated, and when you're on the curve, it's saturated. But again, this is kind of a popular topic. You'll also learn how like if you have a certain value on the X and the Y axis, you can go up and you can be like, oh, that's saturated. Or if it's like here and here, oh, that's super saturated. So you'll also use the chart to get specific information and make some specific calls at specific ranges. And then finally, electrolytes. This is going to be coming up, and it'll be important later also. So electrolytes, if it's strong, it's going to be something that breaks apart completely in water. If it's weak, it'll break apart a little bit. And if it's a non-electrolyte, it'll dissolve, but it just doesn't dissolve for the same reasons as those ones dissolve, and it does not break apart when it dissolves in water. So those are the topics from Module 1.